where there's fewer confusions going on than there are for tonight. That sometimes we buy beer, but thankfully Ray Batcher back there supplied some this evening. So if you enjoyed one of those, big thanks. And we have, as you've probably heard already, many tchotchkes, magazines, stickers, t-shirts, and various things back there. Definitely help yourself. None of us want to carry any of that back home. And there is a list, and I'll pass it around once things get going, and I'm sure that pretty much everybody showed up who can show up. If you haven't signed the list, there's no like personal information beyond your name and company and title that they'll be calling you. So don't worry about that.
Although if you want me to call you, I will. But it'll be at like Sunday 2 a.m. when I'm drunk.
But he's got his card there, so you can call him.
At Sunday morning at 2 a.m.
Sunday morning, 2 a.m. So yeah, that's just to kind of account for the pizza, and since they're buying us food and drink, you know, it's good to be nice. How many are here first time DCP? Okay, that's about good. Well, welcome. We're here every month, second Wednesday of the month. We have a different topic each time. And sometimes they even have them organized a full month in advance, not this month. We also have happy hour meetups that happen. The DC version of it happens every month at
fourth Tuesday of the month at Meridian Pint.
Meridian Pint. If you're local to DC, that's a good one to do. And periodically, every 3 months or so, I'll have one out in Northern Virginia for the people who are too far out for some of this stuff. We'll do some, we'll have the talk, and then afterwards we'll do a quick around the room of anybody who's hiring or anybody who's looking for work, and any announcements that anybody has relevant kind of to the community. And then usually a few people gather and head out afterwards, frequently going over to GBD, which has fried chicken and donuts, which is never a bad thing, but admittedly everybody's had pizza, so maybe it's just the craft beer they have. You know, that could also be an attraction. So Jordan has been, he was just explaining, been in the Nashville tech scene for a while. And I think I kind of got to know you online, you know, from that. Cal Evans, and yeah. And
the Godfather.
Yes, the Godfather who connects us all, Cal Evans. And if you've gotten much involved with DC PHP or the PHP community, you'll meet him. It'll happen. Then last year he moved to DC and helped us out as a volunteer at PHP World, which is very.
Me and Cal Evans both left Nashville. We can't actually. Neither of us could stand to stay in Nashville without the other.
Yes.
So we both moved. He moved to Miami.
Yeah. And where he does things like go diving all the time and throw it in our faces. So that is next week. There are still tickets left. If you are kind of on the fence about going, I can get you a user group discount. Or if you're nonprofit or with government, we can also get pretty much the same discount. So we can get that for you. Just talk to me, and I can help hook you up with that. I just did get the answer. There is free parking for attendees.
Awesome.
So that'll be free for as much of the time as you're attending. So without further ado, Jordan had this idea of a talk he was going to do about Node.js, and from the perspective of somebody who's done a lot of PHP. So I thought it would be a really unique and interesting talk for us. So take it away.
Thanks, Andy. Yeah, so I fully acknowledge the oddness that is doing a Node.js talk at a PHP meetup. And again, one of the reasons that I'm doing it for a lot of reasons, but one of the reasons is, let me just ask the crowd, how many people here have only ever programmed in one language ever, and only ever to expect to program in one language? I've got a 3 there, which I'm assuming means No, I write in 3 languages, and that's one of the points is that we don't ever write in one language. And even if we did our work only in one language, we want to be exposed to languages to see what else is going on because it can influence how our language operates. For example, PHP has been significantly influenced by other languages. We'll see one significant example of this today, which is NPM, the Node package manager. Anyone know what NPM influenced?
Composer.
Composer. It was pretty much taken wholesale and then added to and changed and made better for the PHP community. So one of the reasons that I wanted to do this talk was to expose the PHP community to Node and just show you what it is, because there's a lot of people that have heard things and maybe they've tinkered a little bit, but they don't understand why Node is important, what people care about it for, and furthermore, how you might spill beer all over your computer.
Oh,
So,
you need to know
That's
this?
okay. This is just the type cover. The type cover is the least
Okay,
significant
good.
part of it. So what I wanted to do was talk about how Node what Node is, first of all. I will do a few comparisons to PHP in some ways, but I'm not going to go really in depth into line by line. This is how PHP is different. This is how PHP and JavaScript can relate to each other in terms of specific functionalities. Thank you, Sandy. If you don't mind dabbing that, I don't know if that'll make it through. We'll find out. So that's what I'm going to cover. And at the end, I am going to talk a little bit about how you can use Node and PHP in unison. And I say in unison, not jokingly, but realistically, why might you want to use Node and PHP, and how might that actually happen? So the title of the talk is Node.js, the 800-pound gorilla, because of course it is a gigantic force in the tech community, and I want to highlight that. My name is Kasper. I'm a developer evangelist, and I work for a company called StrongLoop. StrongLoop was very recently, 6 weeks ago or so, acquired by IBM. Wow. So I'm now part of IBM. I have a little badge and everything. And StrongLoop historically has done a lot of things. In terms of releases, we have 5 of the top 10 core contributors to Node. That's the V12 release. I have someone actively working on the 4.0 release, but I don't have those numbers yet. We are the largest corporate contributor to Node Core. This guy here, Bert Belder, you'll see a slide a little bit later, he works primarily on libuv, which is one of the C++ libraries underpinning all of Node. Ben Nordquist there actually is the single largest contributor to the Node Core for the V12 release. And then we have a bunch of other people. Sam Roberts here is currently on the technical steering committee for the Node Foundation. So when Node decides what direction they're going to go, Sam's one of the guys that's involved there. All these people are employees of StrongLoop. And the reason I bring this up is because it's to highlight the contribution. I don't know what happened there. This is just a fantastic presentation.
And it's all on tape.
So the point of me bringing up all this is that we are. Oh man. There we go. That is fantastic.
The computers are lush. One drink and it's all ready.
Right?
The wonders of Windows.
So what we're going to do is restart this machine, and in the meantime, I'm going to tell you about Node. So, oh right, because I got to update. It's Windows. Isn't that great? So I carry this tablet around because it's actually really, it's really convenient, very efficient. It's actually a really powerful machine for its size, and it travels great. Great on planes, great at conferences. Battery lasts a really long time.
But the system.
But it's Windows.
Yeah.
So the reason that I tell you that about StrongLoop is to highlight the fact that we're really involved in the community. We are very much invested in the community moving forward. Again, one of the reasons that I'm out here is to grow and evangelize the technology in the community. So that's one of the sides of StrongLoop. In addition to that, we are the corporate maintainers of some other frameworks like Express. Who's heard of Express? Yeah, like even if you haven't done Node, you've heard of Express because it's by far the largest web framework for Node, and we help maintain that. Loopback is a REST API framework built on top of Express. We wrote and maintained that. We wrote a process manager. We wrote monitoring tools, debugging tools, profiling tools. So we wrote a bunch of other tools that interact with with Node and make Node better. So that's what StrongLoop does, and we'll see a little bit at the end of the licensed software, how we make money bit, and we can talk about that. And if you have any questions, I'm happy to discuss those. Let's see if I can get these slides back up. What we're actually going to talk about, of course, primarily is what is Node and how do you use it at a very low level. And the reason that we're going to do that at a very low level is because I want you to have some familiarity with it. As I mentioned, I'm not actually going to really discuss a whole lot of comparisons to PHP, with the exception of talking about. I can't do my function keys, so I can't do F11 and maximize it. Oh, well. With the exception of things like, what's the difference between object-oriented programming in PHP and in JavaScript? If you're curious about something like that, however, I would highly encourage you to check out my blog. It's jordankasper.com, and if you just Google Jordan Kasper, you'll find it. And the first two posts are a two-part blog series on object-oriented JavaScript and specifically how that works out. If you're curious about specific comparisons to PHP, I would encourage you to check out the PHP Architect. February and March, maybe, or March, April, I forget. I did back-to-back entries in those magazines. So check out some of the archive versions of PHP Architect. And of course, this doesn't work now because
There you go.
well, no, it works when I do this. It doesn't. The clicker doesn't work.
Oh.
So this is what we see as the environment right now. You've got a lot of different backends, right? You might have some services that you're hitting. You might have some database that you're hitting. You might have some other cloud instance that you're hitting. You might just be some PHP or some legacy Java application. And what we want to do is expose all of that over APIs to myriad devices, right? It might be your computer, but it might be your phone, and it might be your car, and it might be an airplane, it might be your watch, and who the heck knows what, right?
Right.
So we want to expose all that over there. And this is one of the best use cases for Node specifically. And it's this idea of microservices and REST APIs. So I'm not going to go through this whole diagram, but this is the idea of the microservice architecture. Each one of these little squares here is actually an individual service. So each one of those would serve up a very particular aspect of your application. And the idea there is that you can modify that, maintain that, redeploy just that one service, and not have to worry about the rest of the architecture and affecting it in any way. So even if this one service goes down or needs to be taken down or needs to be redeployed, you don't have a problem with the rest of the service architecture. Now, of course, inside of that, you might have multiple models going on, you've got various connections going on, and of course, at the top, you've got some kind of gateway problem. And so what we're advocating is for these microservices, Node is a great solution, and we'll see why. So first of all, why Node.js? Why bother, right? It's fast. And when we talk about Node being fast, because a lot of people say, well, it's JavaScript and it's interpreted. Well, first of all, I don't know if you heard, but PHP is interpreted too. So the point is, you're not compiling this code. Now, a single line of compiled code compared to a single line of uncompiled code that has to be interpreted and run, yeah, the compiled code is going to be faster. That's not the efficiency that we're really talking about. The first efficiency we're talking about is non-blocking I/O. And I'm going to talk a lot about this in the next couple of slides. But that non-blocking input-output, whether it's files, databases, HTTP calls, that non-blocking I/O is going to get us a lot of efficiency. We'll see how in just a minute. The other reason is this arms race. Who lived through the browser wars? The old browser wars. Yeah. So in the 90s, late 90s and early 2000s, there was a big browser war between various different browsers, and unfortunately, IE won. They just killed it, and then they stopped killing it, and that's the problem, right? Is they stopped killing it, and we had this huge gap. But we're in a new age of an arms race, and it's this JavaScript arms race. The engines that execute your JavaScript within the browser are growing at an amazing pace. Now, Node is built on top of V8. You might have heard that before. We'll talk about that again in a minute as well. But there are other engines. Firefox uses SpiderMonkey, getting very fast. IE uses Chakra. I don't know if you've seen the stuff about Edge, but Edge actually has a really, really good engine in it. It's getting much, much faster. So that arms race is driving the speed of JavaScript execution up and up and up. And that helps us a lot with Node specifically, because again, we're built on top of V8. It's a bit of a joke, right? One language will do well, ha ha ha, you use JavaScript on the front end and the back end. But it's really not just that you can use it. It's that everyone here has probably written a line of JavaScript. Everyone here has probably read a lot of JavaScript code. The fact is we have an institutional knowledge of JavaScript in our communities and in our enterprise environments that we need to make use of. We're seeing this all the time, StrongLoop. When we go into an organization that's converting from Java to Node or to anything, the first thing they always say is, well, we've got all these people that know JavaScript. that aren't doing it because we don't just have that much front-end work. We'd like to put that knowledge to use. So this is one way of doing it. The really solid standard that is now developing. It didn't exist a long time ago, kind of like the browser was, right? But this standard, ECMAScript, is increasing at a very good pace now. We're getting features locked in annually. That was the change from ES6 to ES 2015 that you might have heard about. The reason for that change was so that features could get locked in for a calendar year. And so next we'll have ES 2016 and presumably 2017, so we can lock features in, and browser vendors can then implement those features without having to wait or do vendor prefixes or all these other terrible things that we've been doing for many, many years. The last thing is the really vibrant ecosystem. And we talk about this ecosystem, we're mostly talking about the package manager, NPM, and the number of modules that are out there. We'll talk about NPM a little bit later. But it's not just that. It's also just the number of Stack Overflow questions, the number of jobs available. If you look at Google Trends, you see Node is just ridiculously through the roof in terms of number of search queries and adoption. So we've got a really vibrant ecosystem with people that are engaged and willing to help and get you successful in Node. And that's one of the reasons that I'm out here. It's one of the reasons that StrongLoop exists. Of course, there are caveats, right? There are always caveats. And one of those is that you have to think in async terms. So before in the browser, it's a little bit easier because you're dealing with user interaction and you don't know when that's going to happen. Async. Now we're doing this on the server. And that async on the server is going to get us a lot of benefits, but we have to think asynchronously when we code. And that's going to cause some issues. And we'll see some of that a little bit later. I'm not going to go too deep into that. One of the reasons that this causes issues is callback hell. Who's heard about callback hell? Yeah, where you've got functions inside functions inside functions, and they're all callbacks from some asynchronous action. So this can be very difficult. We have to be able to manage that asynchronicity, and that's definitely a big caveat. A lot of our frameworks and tools are not terribly mature yet. They're getting there, but Node is about 5 years old. We just don't have the time yet to have invested that much in those frameworks and in those tools. StrongLoop was trying to help with that, with Express, with Loopback, with our monitoring and profiling tools, but it's going to take some time for us to get there. So those tools aren't as mature yet. They're getting there. And then, of course, all these JavaScript quirks. And one of the reasons that these JavaScript quirks still exist is because JavaScript, from day one, has always had this ethos of permanent backwards compatibility. I wrote my first line of JavaScript in probably 96, 97. It was toward the end of the year, because that's when I got my computer. And that line of JavaScript, that JavaScript block, would still run today on modern browsers because of that permanent backwards compatibility with no changes. Now, it would probably be terrible, terrible code, but it would still run. And that was the idea behind JavaScript the entire time, and it has not changed, and it will probably persist for forever. And because of that, these quirks are not going to go away. Right? Those quirks that existed for whatever reason are never going to go away. So we just have to learn to not necessarily code around them, and certainly not rely on them, but to code well, just as you would with any other language, and just do things simple and do things right, and don't try and use those to your advantage. Avoid it. Now, Node is single-threaded. You might have heard this before, but that's okay. We're okay with Node being single-threaded. I'm going to start with a diagram of any other language. Not any other language, but most other languages. Something that has multiple threads. Now, this could be your Java application, or it could actually be PHP. When an HTTP request comes in, it gets handled by a process, right? So let's say you're running Apache and you've got 4 PHP processes spun up, right? Your request comes in and it hits process number 1. Process number 1 is completely consumed until that request does everything it needs to do. Database calls, authentication calls, file reads, whatever it needs to do. It does everything, all that processing, all the production of the response, and then spits out the response. And that process is completely consumed for that entire time. So once process number 4 is consumed, what happens with request number 5? It sits and waits, right? It has to. And that blocks your server, right? Any new request coming in waits. Node doesn't do that. Node takes a different approach. We have this concept of the event loop. And what the event loop does is it's going to handle any function that's going to execute. And on top of that, we have an asynchronous I/O system. And that asynchronous I/O system is going to say, well, you're trying to do something asynchronous, so I'll take care of that and free up the event loop to do something else. So here's how it works. Request number 1 comes in. What's the first thing that an HTTP request typically does? Maybe, I don't know, authentication? Or maybe look up session information. And where's it going to look up that session information? It could be in memory, but if you're doing things at scale, it's probably going to be in Redis, Memcached, Mongo, wherever you're storing that session information, right? That is an asynchronous action. It is something that is hitting an external process, right? So the request comes in. The first thing the request does is it says, I want to check Redis for this person's session data. It does that by passing off, delegating that asynchronous action to a POSIX thread separate from the node process that will do that I/O. And when that I/O is done, it'll tell the event loop, hey, I finished what I was doing. Here's the callback function for that one action. But in that meantime, the event loop is empty, which means when request number 2 comes in, immediately after request number 1, it almost immediately gets processed, even though request number 1 is not done yet. And request number 3 and 4 and 5, because what are they all doing? They're all going to do some asynchronous action, like hit Redis for the session data. And if they're all doing that, then request number 1 is going to do that, and then 2, and then 3. So if you take those 4 processes in PHP or Java or Ruby or whatever, and you take the same number of 4 processes in Node, I guarantee you, you're going to have a ridiculously higher amount of efficiency, of throughput on the Node application. Now, there's caveats to that, right? If you're doing any kind of CPU-intensive tasks, which means you're not doing asynchronous actions, you know, statistical analysis, production of a PDF document, reporting tools, things like that, then you're just doing it all in here. And if you block this, if you block that event loop from doing another action because you're not doing asynchronous things, then you're just blocking the event loop and nothing else will process. So there are caveats there, but for simple web APIs that are just serving up data, this is going to be really, really efficient for us. So I haven't convinced you yet. Here's a huge diagram of a ton of companies that are using Node in production. This isn't just small companies, right? This isn't just like little hipster languages. Big, big companies are investing in this. PayPal, LinkedIn, Netflix, huge investments in Node. LinkedIn converted everything they're doing in Node. They reduced the number of servers from over 90 to 27 and got a 20% increase in efficiency for their API. Okay, so what's Node at the core level, right? That's what we want to know. Well, first of all, it's not JavaScript, precisely. Does anyone know why it's not actually JavaScript? No one knows why it's not JavaScript?
It's ECMAScript.
It's ECMAScript, very good. Why isn't it JavaScript?
There's no DOM.
Because JavaScript is a trademark term. It was trademarked by Netscape, which was purchased by Sun, which was purchased by Oracle. JavaScript is a trademark term by Oracle. So Node is an implementation of ECMAScript. So it's ECMAScript. Well, it's a standard, right? It's a language specification that identifies features that have to be implemented in order to abide by the specification. And there are a bunch of implementations of this. V8 is an implementation of JavaScript, of ECMAScript, which they call JavaScript in common practice, by convention. SpiderMonkey in Firefox, Chakra in IE, which of course used to be JScript, but they've stopped using that term, they just use JavaScript now. Tamarin for Adobe's ActionScript for Flash, and Rhino. Has anyone actually used Rhino? No. It was one of the first server-side implementations, and it was a Java implementation of the ECMAScript standard. So Node builds on top of V8. I talked about that earlier. So V8 is the engine underneath Google Chrome. It's the thing that actually executes JavaScript. And on top of V8, we've got some C++ libraries. libev, which is the thing that handles that event loop. libeio, which handles that asynchronous input-output. And libuv, which you might have remembered I mentioned earlier. One of our guys actually is a primary maintainer for this. libuv is an abstraction layer on top of that the standard Node library interacts with, and then interacts with V8 directly. And then, of course, there's the standard library that provides all of the various core functionalities that you execute, the file system and the buffer and stream implementations and things like that. So just a brief diagram here. Of course, your application at the top, V8 at the bottom. There are some other modules that I didn't mention, operating system specific stuff. Obviously, you need an SSL module to be able to handle that. You need C areas for DNS hookups, and you need a bunch of other stuff, right? So all those things are kind of pulled in at the C++ level. So one of the biggest differentiators from Node and browser JavaScript is the module system. There are, of course, other differences, but the module system is one of the biggest differences. So this is a very basic module usage. Some of you might have already seen this, some simple examples of this. We've got a statement called require. Now, it is very similar to your PHP require, but I'm going to talk about the differences in just a minute. Suffice it to say that it goes and it finds that module, executes the code in that module, and then brings back whatever the output of that module, the API for that module, and places it on this variable. It aliases it to that express variable. Now, I could have called this whatever I want, var express. I could have called it anything. It could have been foobar. It doesn't matter. It's a local alias for this executing code. Now, I know that this module exported a function. And so you can see that I'm now executing that function on the second line. Keep pointing to it. I have a little later pointer right here. But since it doesn't work my slides, I thought it wouldn't. It came back on.
Oh.
Gotta love that. Windows.
It keeps you guessing.
Yeah.
Wait for it. Half an hour.
So now I execute this variable as a function, and I get back something which is whatever that returns. So this is me initializing Express and getting an Express application. Yeah. So where does it get those modules from? It can get them from lots of places. So at the top, we can see it gets a core module, FS. FS is, of course, the file system. I require Express. It gets me back Express. I can require other things that I create. And where does it get all these? Well, first of all, that top one is a core module. The second one is a module that I've installed. It's not a core module, but it's not something I wrote, right? So how does it know where to get it? If you look very closely, you'll see that the last two lines have a slight difference from the top two lines. There's a dot in front. That dot indicates, hey, I want you to go load a file or a directory, not necessarily a whole module. So if there's no dot in front, the first place that Node is going to look is in your Node modules directory, which is where all of our dependencies live. That's where npm installs things to. If it doesn't find it there, it will try and look in the core file system. And if it doesn't find it there, you're going to get an error. You get a reference error. I can't find that module. Can't load it, and I fail. If there is a dot in front, it actually tries to load up that specific module. So here I've said, go into the app directory and look for a file called router, and it will automatically append a .js at the end, so you don't need to have that. If that is actually a directory, then it's going to look at that directory and try and figure out what file it should load, and it determines that from the package.json file, which I'll talk about in a minute. Two dots, just like anywhere else, goes up a directory, right? So it says go up one directory, then go into the config directory, and then load this JSON file. So require can actually load a JSON file, and it will actually put that JavaScript object on this config variable right here at the bottom. So we'll load that up and put it onto that variable, just parses that JSON for you. So this is generally how we use require. Now, as I mentioned, it's like the PHP require, but not exactly. We'll get to that in a second. I want to talk about some really simple modules, right? So this is a file called my module. You can see that it does a console.log, right? Console.log hello world. I'm guessing everyone knows what that's going to do. Log out hello world. In this case, not to the browser, of course, but to the server console where you've executed this file. Now, in my main.js, I'm going to require that. Notice that I don't get anything back, right? Because the top module doesn't give anything back, right? There's no API to give back. It just executes code. So you don't have to do var something equals require. You can just say, I want to require this file. When I execute this, I execute the main file. You can see it will print out hello world. So it's going to go and grab that other file, mymodule.js. It's going to do a file read, system file read, and then it's going to execute the JavaScript in there, do whatever that JavaScript does, and then return. And that's it. But of course, we want to do something a little more complex, right? A lot of times we want to return something from our module. So let's talk about creating module APIs. The first thing we're going to do is just export a simple function. Notice that this function just says console.log whatever. In this case, it takes in a recipient, and it echoes out that recipient. When I require that module, you can see I put it onto the foobar variable, because again, it doesn't matter what that variable is called. And then because I've exported a function, I then execute that function right here, foobar with StrongLoop as the argument. So what's happened is, again, when I do a require, it reads that file, it executes all the code in that file, and then it will look for this variable, module.exports. Anything on module.exports becomes the return value of the require function call. If I said module.exports 42, then the require function here would return the number 42. Okay? So it just returns whatever's on module.exports. Nothing special. Anything on there will get returned by the require statement. So what about PHP? Is this really just like require file.php, it's close, but not quite. When you require something in PHP, by just doing a require statement, when you do that, it brings in everything from that file into the context in which it was required, right? So I'm in file A, and I require file B. That basically is just like I had put the code there. That is not true in Node.js. In Node.js, you only place, or the only thing that will come in is whatever's on that module.export's value. So it's only whatever you've exported that gets pulled in. All the rest of the code immediately gets executed as if you would just run that file. And whatever's on module.exports gets returned from the require function call. Additionally, each module has its own scope, its own variable scope. So when I pull in PHP, if I've got file 1 with function foo and I require it down here, foo is immediately available. But in Node, I would have to require that file, place it on another variable, and then execute that local variable, because each module has its own variable scope. All the variables defined within a module are only available in that module. They're local to that module. You must export them to get them out. Make sense? Additionally, we don't have any distinction between include and require, and if you don't know any distinction between include and require in PHP, really the only difference is whether you're going to get a warning if that file can't be loaded, or whether you're going to get an error and stop. In Node, require always produces an error if it can't load the file, or if it can't execute the file, right? If you have a syntax error in your JavaScript in the external module and it can't execute that JavaScript, you will also get an error. There is no alternative. So we have different module patterns, different ways that we can load this up. You saw me create a simple function and export that function. Exporting a function is a very common pattern, but I want to talk about one other pattern, which is this simple object API. So let's presume that we want to create some little thing like this, right? It exports the name, version, and a little say hello function. That will work just fine. When I require it, I can require it, place it on a variable like API, and then I can do API.sayHello, and I can do API.name and API.version, just like you would with any other JSON object, right? So why not just always use those, right? And the trick is modules are cached. And when I say modules are cached, what's actually cached is whatever is exported from the module. So here I have a little worker, right? So this is worker.js, and I'm going to require worker.js. Notice that it exports a little object for my worker, right? Salary and a method to give that person a raise. So now I'm going to require the worker module into worker 1, and I'm going to give worker 1 a raise at 10,000, and then I print out their salary, and you can see it's 60,000. Great. Now I require the module a second time in order to get a second worker in the same file. Or, by the way, any other file in your application. It does not have to be in the same file. And now I give that worker a raise, but unfortunately that worker's salary is now 70,000, not 60,000. Why? Because whatever was exported is cached. When you do a require statement, Node first looks in the cache and says, do I already have that module? Oh, I do. I'll just return you what I already have. And because objects are passed around by reference, when I update the salary for one instance of that object, guess what? Everything is updated because it's one place in memory that is referenced by lots of different pointers. Make sense? So because of this, if you're using the object API, you've got to be very careful. Exporting an object that has a bunch of functions on it, probably fine. Exporting an object that has data on it that you might manipulate, you need to be careful. Okay? So the question is, how can I implement something like this? Very easily. We're going to use it doing the revealing module pattern. So the revealing module pattern is this idea that you export a function which actually creates the thing that you want to get back. So I create a function wrapper, and you can see the thing that the function returns is my object with the salary and with the give raise method. I've done a little checking here of the options value to say if you gave me a salary, use that, otherwise default to 50,000, but otherwise it's basically the same object from my previous example. So now when I require the worker module, I alias it to this local variable, right? And then I execute the getWorker function, passing in my options, and now I can actually create a second worker, and they will in fact be two completely different objects that I can then manipulate independently. So this is considered a revealing module pattern, where the function is really more of an initializer, and then you return the object that you actually want to interact with. Now you might say that looks a lot like a constructor function, right? Where you're creating an object, and it kind of is, and you could implement it that way as well. Now I don't go over how to do object-oriented programming in this talk because I don't want to intermix those things. Again, if you go to jordankasper.com, you can find 2 good articles on object-oriented JavaScript and what it really means and what it looks like. But the alternative here would be basically to export a constructor function from this module and then be able to construct new objects from that. So how do you actually use whatever module, any module? How do you use it? Well, first of all, you need to read the docs, right? Now, if it doesn't have docs, use a different module. And this is true not just of JavaScript, right? This is true of PHP as well. How do you select that you want to use a particular module to do whatever random task? I usually have 4 factors that I look at. The first is development velocity. Has this thing been touched in the last 6 months? If it hasn't, I'm probably not going to use it. Does it have more than one contributor, more than one maintainer? If there's a single point of failure, you might want to rethink that, because if that person goes away, you're SOL. Does it have documentation? And does it have tests? Are there tests where I can run those tests and say, yes, this is doing what I expect it to do? If it's got those 4 things, then yeah, I'll probably take a look at it. What if it's not used by very many people? What if it only has 2 GitHub stars? Who cares? If it does what I need to do, it's got really good tests, it's got really good documentation, it's being actively maintained, I don't have a lot of problems with that, with it being relatively new. And this is one of the biggest benefits of Node, is NPM. It is the package manager, and it's the module system that we have. It's the fact that we have so many modules. When you want to go and do random task X, there is a module to do it, I guarantee you. There's probably 20 of them, which gets us back to, of course, how you pick them. But this is one of the best parts of Node. So of course, it's a package manager. It's also the website where you can search for packages. It's a command line tool, NPM, where you actually install your dependencies and your packages. And it also maintains registries, both public and private. So if your enterprise wants to go and have their own registry, NPM will host it for you, or you can host it yourself using their software. So the very first thing that we need when we start working with NPM is a package.json file. And in fact, anytime you're starting a Node project, you should start by creating a package.json file. This should be the first thing you do. Not write a line of code, create a package.json file. Because this is going to hold all of the meta information about your project and about your dependencies. It's really very easy. You can do npm init from your project directory, and it will create that package.json file for you. It will ask you some questions, or you can just hit enter and it'll do all the defaults for you, or you can do -- something, and it will just do all the defaults. I forget. There's an option to just, it'll do all the defaults for you without you asking. This is what it might look like. Look familiar? Kind of like a composer file? Yeah. So there's a couple of things in here. The name is pretty specific, all lowercase. Typically we use hyphens between words, but there are a little bit of variances there. It can't start with a number or I think a special character, so keep that in mind. Versioning, we tend to use semantic versioning in Node, but you don't technically have to. This one is not set for you, private, set to true. It's not set for you with the default npm init. And I highly encourage you to always set it, because it prevents you from accidentally publishing this module before you're ready to. I'll talk about publishing in just a minute. This main entry right here indicates the first file that should be executed in your project. So you might say, well, it's a web application, so it's the server file, it's the entry point. I'm like, okay, great, but if you're writing a consumable module, something that someone else will reuse in multiple projects, what you need to tell them is, what you need to do is tell Node, when I do a require, what file do I execute first? And it's this one, the main file. And then that file could require a bunch of other files and pull things together and produce the module.exports that the other application consumes, right? This is how Node knows which file to begin execution with in a directory. And then, of course, we've got author, license, dependencies. We'll talk about dependencies a little bit more in a second. Scripts, Node actually, NPM specifically, has a built-in script runner. And you can really write whatever you want in here to do scripts. And you can do pre-test and post-test, and pre-install and post-install, and pre-start and post-start, and really actually build up a pretty elaborate build, deploy, execution scripting system just with NPM. A lot of people actually advocating for moving toward that, and instead of things like grunt. I'm not there yet, but it's an interesting idea. So you want to install some dependencies, right? We want to use Express, maybe we want to use MongoDB, Lodash, Redis, whatever. You do npm install in your project directory and then the module name. npm will go out and look for it in the public registry, pull it down, put it into your node modules directory, right? So my project / node modules with all those packages under there. Notice that I can do multiple, right, at one time with just spaces in between. But you almost always want to add one other thing. What is it, Juan?
-- save.
You always want to add -- save. I love having a nodie in the crowd that can do that. You always want to have -- save because that's what's going to automatically add that package with the current version to your dependencies block in package.json. Or if you do -- save -dev into your dev dependencies, right? So here you can see that I put grunt in my dev dependencies, build time, compile time, not runtime, right? Express I need all the time when my application is executing, both in dev and prod, so I've got that in my regular dependencies. A quick note on the semantic versioning here, and Composer uses very similar terminology, so you might be familiar. If I've got a caret in front, what does it mean? Does anyone know?
Start the file. Start the never mind.
Yeah, you're thinking regular expressions. You're absolutely right. It's the start of the line of regular expressions.
So you have to match the like major, the minor, but not the patch.
Close. So caret, because it's beginning of line nomenclature, right, is the first significant place must stay the same. So 4.12.5 would be okay, 4.12.10 would be okay, 4.13.10 would be okay, but 5.0 would be right out. But if you use the tilde sign, the little wavy thing, you know, that we English speakers don't know that well, when you use that, it means the least significant can change, but everything else must stay the same. So if you have a tilde, 4.12 must stay the same, but it could be 4.12.5, 4.12.10, 4.12.99, that's fine. You can also do an X in any of these places to make a wildcard match. You can also do just star in quotes. Do not ever use star in quotes for dependency. Hopefully, I don't need to tell you why, but when a major version changes, you're going to have breaking changes. That would be bad for your runtime. Okay. Global packages, you've probably already, who has installed a global package at some point? Most of us, right? Grunt or Bower or whatever, right? So StrongLoop is our tool chain. I'll show you a little bit later. Grunt CLI, of course, and it's the -g, right? Or -- global if you prefer. And that installs it not into your project directory, but into your user directory, right? Now, that's great, but you should never use globally installed packages in your project. You don't use those in your project because then when someone else comes on your team and needs to get the project up and running, how do they know what to install? They don't. It's on your system globally, not in the dependencies of your project. So global dependencies are for tools, right? Grunt, Bower, Mocha for testing maybe. Something like that, not for Express, things like that. Okay. When you're ready to publish a module, step one is to create your account on npmjs.com. So you wrote a little tool, you want to get it out there, go to npmjs.com, create an account. Then go to your command line on your system and do npm add user. It'll ask you for your username, password, and the email address. That connects your system with the npm.js registry. And then it's simple. You go to your project directory and do npm publish. Boom, it's up there, period. Now make sure you do have your repository field filled for your package.json so that npm knows where to point people to and whatnot. So you want to really flesh that out, right? The package.json file. But otherwise, this is it. You just publish. And remember the note there, right? I need to set that private switch to false. Otherwise, you'll just get an error. It'll tell you you can't do this. It's marked as private, which is what we want while we're still working on that module, right? All right. So I'll talk about some other node specifics. So we've gone through a lot of like differentiating factors. Everything else from here is really it's just a library that you use, but it's just JavaScript code. So we've got the global context. In browser JavaScript, that's window. In Node, it's global. And just like with browser JavaScript code, you should not be putting things on window, right? You might put one thing in browser JavaScript, a namespace maybe, and everything goes under there. But you should not be polluting that global namespace. And for the same reason, you should not be polluting the Node global namespace. And you don't even need a little like window dot, my app namespace in Node because you have your own scopes in every module, so you don't even need that. What's on the global object? Things like require, things like the console, things like the process. These are all properties of the global object. So when I just say console.log, what I really mean is global.console.log. Like in the browser, I say console.log and it's actually window.console.log, right? It assumes global if you don't put it there otherwise. And again, don't use global for inter-module communication. You want to be passing data from one module to another using global. We do that through function calls and the exports object, right? The node process is your inspection into everything about the system process that Node is actually executing within. So everything on there from environment variables, command line arguments, the process ID, all sorts of things about your currently executing Node process are on that process object. This is similar to your $_server, $and variables in PHP. Same idea. You've just got a collection of data that describes the environment in which things are being executed. So some of these other built-in libraries, of course, HTTP is the big one, right? Now, PHP got a built-in web server in 5.3, right? I think it was 5.3. People are nodding hesitantly, but no.
It's 5.4.
It's 5.4, you think? Okay. Anyway, you got a built-in web server, and what do they always tell you about that built-in web server? Don't use it in production. Guess what I'm going to tell you about Node? Use this in production. This is exactly what we do. Node is built for network applications. That is why it was created in the first place, is for network applications. The HTTP server, of course, one implementation of a network application, but that's what Node was built for. So this is your more or less hello world. And I've got a couple other things thrown in here to just do some examples, right? So you can see I'm requiring a couple of core modules, HTTP and a URL parser. The URL parser, again, just parses URLs, gives me a little help. I'm going to go to the HTTP module. Remember, it's an API that's been exported from that module, and I'm going to create a server. I pass a function into that function. See that? Functions and functions, right? So I pass that function in. This function right here, this big function here, is what will handle an incoming HTTP request. That's the entry point for all HTTP communication. It will be given the request and response objects, and it interacts with those. You can inspect the request object like I am here, looking at the URL, parsing it out, and then grabbing the path name, checking to see that I'm matching the root, and if I'm not on the root, you can see that I return a 404. If I'm not on the root, then I'll write a 200 status code, a content type of text HTML, and I'll response.end with, with ampersand LT semicolon. No, you would respond with, of course, angle brackets, right? I would respond with hello world with a little bit of HTML. So this is my very basic server. This is the code that's actually going to get executed when I get an HTTP request come in. Notice down here, I actually have to open it up, right? So that's the handler for the server request. This is the opening up of the server. You can see that I give it a port, I give it a host, and in this case, it's just the loopback host, so the one that's on this machine, and then a function. Why do I have to give the listen call a function? Because it's asynchronous. Remember, everything is asynchronous. If I put this log message that the server is up at the last line here, and I don't put it in this function, then the server is not up yet. I've executed a request for the server to be up, but opening a port, does anyone know what happens when you actually open a port on a machine? You actually create a socket connection, and that socket is actually a handle. It's very similar to a file handle or a directory handle. It's actually something that actually has to hit the operating system and the file system. Well, to do that, it's an asynchronous action, because remember, everything in Node is asynchronous. So opening up this port is asynchronous, which means I have to have a callback function to handle that response and do whatever I want to do once the port is open. So yeah.
Is the reason why server.listen doesn't have to be in the callback of create server because the listen function will just wait and not execute before?
So notice that it's a good question. So notice here I'm executing the create server function, right? And I pass it in another function. This inner function does not execute, right? It's a function that will be called when I get a request. So if I never open up the port, can I ever get a request? I can't, right? So this has to happen outside of this function because otherwise it would never get in there. So I listen to the port, and then when I get my HTTP request, it will eventually execute this. This isn't, strictly speaking, a callback function because create server isn't really an asynchronous action. It's actually, create server is actually an action that says, hey, I want you to create a server and attach this function to that server. It's actually a synchronous activity. Opening up the port is an asynchronous activity, which is why I have a callback function.
Technically, handle requests is a callback for when the machinery in there eventually gets request and it calls the callback.
It will be assigned as a callback function to another action. It is not the callback function for create server.
Yes.
There is no callback function for create server. It's a good distinguishing. Thanks.
Does the console log at the end there run every hit then, or just the one?
No. So this is the callback function just for opening up the port. So it will not run every time we get a request, only once the port is opened. This function will execute on every request because it will be passed through as the callback function for the request event on the server object. If you want to get down. Okay. So here's another asynchronous action. Of course, we have full access to the file system because we're on the server, right? And in fact, this is a good pausing point. People always say, well, Node's not secure, right, because it's JavaScript. Node runs on your server. Any code that runs on your server is only secure as your server. It has nothing to do with the language. It has to do with where you're executing the code and what security measures you have on your server. But in respect to security, it is no different from a PHP or a Java or a Ruby or any other language that's running on your server. It's on your machine. It's not on the browser, right? So you got to keep that in mind. Any security factors that you would have with PHP on your server, you're going to have with Node. When the OpenSSL hit that attack came out, that attack vector, it affected everybody, right? It wasn't just Java or just Node or just PHP. It was everybody. There's a module that was being used on the server. Okay, so I've got access to the file system, like you would in any other server-side language. I require the fs module, and you can see I just call fs.readFile. I pass in the file name, and then I pass in what? Callback function, because everything's callback functions. But I do want to point out one thing in this particular callback function that we didn't actually see here. This is a little bit unique of a callback function. This is much more typical. And the reason is this is a Node-style error-first callback function. And this is what you're going to see everywhere in Node. So you need to get used to it. If you start doing Node, you got to get used to this. The callback function will almost always have an error object as that very first argument. However, if the action that you're taking, in this case reading a file, did not produce an error, then that first argument will be null. And if it was an error, then data would probably be undefined, and the error object would be filled with an actual error object. Yeah? So first thing you do is you always check for an error. Handle it however you're going to handle it, log it out, do whatever you got to do, and then return, right, so that I don't keep going. And then, handle your data. In the file system, by the way, data by default is returned as a buffer object, which means I have to decode it, convert it into a string using UTF-8 decoding or encoding. So you have to do that if you use the file system, but otherwise it's pretty much the same. Yeah? So again, the reason I highlight this one is data is this function is a callback function, and it's going to use that error-first style syntax. So you have to be familiar with that if you start working with Node. Now there are other ways to do this, of course. You could implement this with promises. You could implement this using an async library. There's lots of alternatives you have here. I don't have time to get into those tonight, but if you're interested in those, I'd be happy to talk about promises over here after. Lots of other core libraries, right? Child processes where you can spawn other processes, streams, buffers, crypto library with full everything you would expect in a good crypto library, bcrypt and all that good stuff. Cluster module for doing scaling where you want to actually have not just one node process, because eventually you're going to need more than one. But when you start scaling those node processes, how do you do that? We can do that with the cluster module. An event system where you can make a module implement the event emitter where it can emit events and have other code listen for events on it. All sorts of other really good libraries. Again, not enough time to go through all of them. I would highly encourage you to check out Node.js.org and look at the API documentation. The API documentation is very good. It is not a guide. It will not help you with writing your first Node application. It will help you if you're trying to figure out how to use the URL module to parse a URL. It will not help you to know how to write a good web application. So I want to talk briefly about data sources. We've talked about writing applications, but of course, one of the big things that we all have to do is connect to a data source. Well, you can connect to any data source you want. In fact, most data sources these days have a Node driver. Oracle just released their official, this was earlier this year, so maybe 6 months ago, their official Node driver for Node, or a Node driver for Oracle. But any other data source that you want, lots of other options, of course. So here's an example for MySQL. You can see that I do --save, right, with my install command, so it goes into my dependencies. And then I would just require the module. Again, it's going to look inside of the node modules directory for this, right? And then I get the MySQL API, which I can create a connection from, local host, whatever, enter all the information that you would typically enter anywhere else. I connect, I can execute a query, select asterisk from books where whatever you want to do your where from. You get back the rows and the fields in those rows. So if you had selected fields, it would actually return you an array of all of the fields that were returned. And then you just, for each over the rows and do whatever you need to do with each row. Pretty much the same as you do in any other language, right? But of course, we don't want to do this, right? We want to do parent statements. Maybe we want to do some ORM functionality. And so, of course, we do have those. So we have ORMs and ODMs. So object relational mappers, stuff you're probably familiar with, and ODMs, object document mappers. And that's for NoSQL databases, typically document storage like MongoDB. So SQLize is the big player. If you're doing any kind of SQL database, it's probably the biggest player that you want to use in terms of doing an ORM. However, if you're using MongoDB, Mongoose is the biggest player by far. Now, if you want something a little bit more abstract, Waterline was actually originally created for the sales framework, but it will do both SQL databases and NoSQL databases. So you can actually connect to both and use the same syntax. So it's kind of nice if you have to connect to multiple different data sources, right, 2 different types. Maybe you got legacy in Oracle and modern stuff in Mongo, and you want to use the same ORM system, Waterline might be a good choice for you. So you use SQLize, npm install, --save SQLize. Notice that I've got the --save in front here, whereas before I had it back. Just to highlight it, you can put it in either side, doesn't really matter. You require it, just like we would require any other module, and then notice that I create a new SQLize. You've got that kind of object-oriented syntax, and I just passed in a MySQL connection string, just like you would anywhere else. One of the nice things about SQLize is it has a bunch of other options, which I'm not showing here, to do things like pool management. So you can have pool connections, and you can manage that pool, timeout, and all sorts of other things that you would need in a more professional or more enterprise system. So once I've created that connection, you can see that I get back a DB object, right? And then I can use that DB object to define some class, if you will, although JavaScript doesn't have classes. In this case, it's user. And notice that I give all the properties, right? And those properties have all sorts of different things. Notice that I have SQLize.string, and then .float. But remember, JavaScript doesn't have floats. JavaScript has numbers. It doesn't matter what type you want it to be, it's going to be a number. So what you're specifying here is when you go from JavaScript to MySQL, I want you to use float for this field. Okay? So that's the conversion that's going on there. SQLize will do that conversion for you and ensure that that table is in fact expecting that type. I go to that return value, in this case user, and then I'm going to sync it. Now, you don't have to sync things, but the idea of syncing is go to the data source and make sure that that table exists with these properties. And you can force it to create it if it doesn't exist. But what you don't want is to try and use this thing when the data source is out of sync, right? When those properties don't exist for some reason. So that's what this sync is going to do for you. And it uses promises, which is why you see .then. So .then is a way of managing callbacks. It doesn't eliminate callbacks, but it allows you to manage callbacks a little bit better. So what you're seeing here is this sync action, what did I just say it did? Goes up to the database, checks the structure. That's an asynchronous call, right? Just like file system, just like the HTTP server opening the port. It's asynchronous. So when it's done, then execute this callback function. That's the idea of promises. Sync returns a promise, and then you execute then on the promise, which says when the promise is complete, execute this function. Now, there are a lot of other intricacies to promises. This is not by far everything you need to do, just the basics. When you're ready to read, I go to my user object again, and I do find by ID. pass in the ID, then, right, because it's asynchronous, then it'll give me back in a callback function that user that was created. And here's my error handling with promises. .catch, which says if an error was produced during that promise, during the asynchronous action of find by ID, then execute this other one with, again, that error object coming back. Good? And of course, we can do things like find. Now, you'll see this a lot in Node, where our find is constructed using a JSON, a JavaScript object. Does anyone know the difference between JSON and JavaScript objects except for one? So JSON is a data interchange format. It is a very specific specification, and you must follow that specification to the letter, otherwise parsers won't work. JavaScript objects are very loose objects that can have whatever they want in them, like this. This is not JSON. In order for this to be JSON, I'd have to do a couple of things. First, where, first name, and like would all have to be in double quotes. Secondly, single quotes aren't allowed, so Jordan would have to be in double quotes. A little bit of trivia there for you. So you can see generally how this is constructed, right? Where, first name, like Jordan. Pretty easy, right? But you can combine these. So I can have where, first name like Jordan, and then I could have comma, last name like something else. Or of course, different operators, and all sorts of other things. This is how we see a lot of the construct of query clauses produced in Node. Not just with MySQL, not just with SQLize, other libraries, other data sources will use this format as well. So I would become familiar with it. And of course, this is producing a prepared statement, right? That's the entire idea. All right, so it's just JavaScript. Yep, it's just JavaScript. So this is all just JavaScript. Any JavaScript knowledge you have applies to Node. You have to get a couple of core concepts: that module system, the fact that each module has its own scope, and of course, how to use those built-in libraries. But otherwise, it's just JavaScript. You're still going to do async calls. You're still going to have callbacks. You're still going to have to deal with all of the normal stuff that you have in JavaScript. It's cool, right? So I mentioned I would show you some things about integration. So let's talk about those. Node and PHP both have their good parts. I actually still like PHP. I still use PHP from time to time. But there are good things that Node gets you. If you're doing a data API where it's just database lookup, spit out the data, Node is really, really efficient for that. If you're producing reports, if you're doing statistical analysis, if you're doing, gosh, I don't know, video rendering, if you're doing anything complicated that's going to be synchronous, then Node's probably not a good choice for that. So, and if you have a legacy system that you're maintaining, but you'd like to do a nice little efficient API built on top of it, we can do that with Node and not disturb the existing PHP application. So let's see how we might do that. First of all, you need to make sure that you're externalizing any of that session data, right? Hopefully you all are if you're doing any kind of system at scale. But if you're not externalizing session data, if you're doing things in memory in PHP, then we're never going to be able to access them from Node, right? So the first thing is to make sure that you're doing things like Redis or memcached for session storage, for authentication, for whatever you're doing. You've got to get that outside of the PHP system. Now, if you're using the file system, that is accessible from Node, so it'd be a little bit easier. But if you're serializing objects to a file system, then Node's not going to use the same deserializer that PHP is, so that's not really going to work very well. So make sure you're externalizing that stuff. But then we can just use Apache or Nginx or whatever in front, send different requests to different systems. They're all accessing the same data, no problem. And in fact, you can even call out from Node into PHP, and vice versa if you wanted to. So now we need a proxy request from that web server, right? So let's say we're using Apache. Who's using Nginx? Who's using Apache? Who's using something else? IIS? WebSphere? All right. So here's the Apache version. So this will probably look pretty familiar to the Apache folks. You create a virtual host, right? It's listening on port 80 of whatever IP address. Its server name is foobar. And down in the location, I can specifically say, well, when someone hits my API, all I want to do is proxy it into Node. So when I execute my Node application, that HTTP server we saw earlier, it was executing on port 3000, right? So locally within the system, it's executing on port 3000. I'm not exposing port 3000 on my system. I'm exposing port 80. But I can proxy request specifically to /API into localhost 3000. I never expose the Node application to the public other than through this URL. Yeah? And the same applies for Nginx. Don't forget, if you're doing this, you do need those Apache modules, right? Proxy modules. Same goes for Nginx. I basically have my server, listing on port 80, server name of foobar.com, just like before, location, /API, proxy pass to localhost 3000. Almost the exact same setup, just a little simpler because Nginx's configuration is really, really simple. So again, all this other stuff in the middle here is you configuring your PHP application and getting that up and running. But otherwise, you can just pass things right through. But you can also take some other things out, right? Especially with Nginx or Apache, you can take out static file serving. No reason to send that to Node. No reason to send that to PHP. Static file serving, pass it up to a CDN or just serve up directly from Apache or Nginx. Much, much more efficient that way. If you are using Nginx, you probably are going to use the fast CGI process manager. Is anyone using Nginx and not using CGI? I just would be curious how you're doing it, because, yeah?
Well, not Nginx, but at FPM I had to drop.
Oh, really? With what?
I don't know. I think the alternative is I'm using XAMPP. Whatever they built in is so much better than FPM.
Yeah. Okay. So if you're going to use Nginx, you're probably going to have to use FPM.
HipHop is the other contender.
Okay, so maybe you're saying to yourself, maybe we can use Node. You can use Node for a couple of things. Great! So which framework are you going to use? Because there's a few of them. This is not all of them. This isn't even close to all of them, right? There are a bunch of frameworks, and it's really hard to pick. So all I'm going to do is go over a couple of framework patterns, right? Pattern number one, convention-based patterns. So this is the, if you do it our way, then things will be really easy, right? But if you try and do things a little bit different, if you try and go outside the box and do things in an advanced way that don't follow our pattern, it could be difficult for you. So these are things like Express. If you do things the Express way, it can be really easy, really efficient. Now, Express is built as an unopinionated framework, and it is. It's very lightweight and unopinionated in how you do anything except for middleware. You have to define your middleware in Express in just the right way. And if you don't, things don't work. So that's how it comes into the convention category. Restify is the same way. Kraken actually shouldn't be in here. Kraken should probably be on configuration. It produces an Express application from configuration. The configuration pattern is the next one. Happy falls into this category. Loopback, the REST API that StrongLoop built on top of Express, falls into this pattern as well for some things, although you'll see at the end it kind of departs from that a little bit. So the idea here is that you have a much lower learning curve and usually much better documentation. Configuration-based, just by its nature, is mostly documentation, so it's much easier to get started with. The weaknesses, of course, they can be very opinionated sometimes because the configuration has to be, you have to do things in this way. This configuration parameter must match these values. You don't have a code block, you have one configuration entry. And a lot of times you might need to do some manual CRUD actions, so that can be a little bit difficult. Isomorphic JavaScript. These are, the big player here is Meteor. Flatiron does this a little bit. Loopback does a little bit through code generation. The idea is you're using the same code on the front end and the back end. So the idea would be you've got your models on the back end, and Meteor literally just takes those models and compiles up a front end library from those same JavaScript files, and then pipes that to the front end for you to use on the front end. So it's literally the same code running in both places. It's really nice because you can share that code client to server. You get automatic endpoint generation and routing really easily, but it is a very high learning curve. It can be very difficult to get started with something like Meteor or even Flatiron. Loopback does this through code generation, so it's a little easier to get started with, but of course, you're not getting all the benefits of a true isomorphic library like Meteor, but it's, give and take, right? And the last one is this idea of an ORM-based or an MBAS, mobile backend as a service library. And Sales fits in this category as well as Loopback. And the idea here is more model-driven development. You write your model, you write all the functionality and all the properties for your model, and you let the framework deal with what comes out of that. What comes out of that are REST endpoints, right? I've got a model, and then I need to generate all those CRUD actions for interacting with that model over an API. And Loopback can do that for you. Sales does that a little bit for you. And it's really nice to have that because you can focus much more on the business logic and less on that boilerplate. But anything that's not really data backed, if it's not, I've got a model, it connects to a data source, I expose these endpoints. If it's outside of that kind of pattern, it can be a little difficult to work with. some of those advanced functions can be a little more difficult to write. So we're at the end. So let's say you're ready to use Node, you're already using Node, and now it's time to scale it. This is where StrongLoop comes into play. This is what StrongLoop has been focusing on for 3 years now. We provide tools for doing all these things: profiling, metrics, monitoring, build and deploy tools, process management, microservice architecture, and now that we've joined IBM, we have our own cloud, right? We have Bluemix, so we can actually integrate all those tools with Bluemix. So if you start building Node applications, you'll find very quickly you need things like build and deploy tools, remote deploy. You want remote profiling and monitoring and process management. All those tools are things that StrongLoop toolchain provides. You can install very easily, npm install -g StrongLoop, and after you do that, you go to your project, your Node project, you do SLC start. One of the nice things about SLC start is it starts in a process manager. We talked a little bit about when you start to scale, you go from one process to multiple. There's a cluster module built in, and you can write your own code to write a cluster of Node processes. It's very nice. The first one, the master, will accept all incoming requests, and it will delegate those requests to all of the workers for you. It's really very easy, but you have to write the code for it. And it does very dumb interpretation of where it should delegate requests. It's just round robin. A process manager, which is what the StrongLoop tools get you, does a lot more intelligent distribution of those requests, more on a least connectivity approach. SLC Arc is our graphical interface into all of these tools. So by installing this module, you get all of these tools. When you first start up SLC Arc, it will open up a browser and ask you to log in. If you register for an account, it's a completely free registration, name and company. There's no credit card or anything required. They get you a 30-day trial license of a lot of our tools. A lot of our tools are open source, and you can use this anyway. Things like our process manager, completely open source. Some of the things that aren't are our more profiling and monitoring tools, right? You want to get nice, pretty CPU charts, CPU usage charts, or memory charts. This is heap memory usage. By the way, does everyone know what this is? What the downswings in this chart are?
That's a process.
No, so this is memory usage, heap memory usage. It's garbage collection, right? So what's that? That's a memory leak. And JavaScript, Node as well, but JavaScript is notorious for memory leaks, right? This is what these profiling tools are built to find and help you correct. So that's why we built these tools, is to find those harder to find issues in Node specifically, built for Node. Profiling tools, heap memory snapshots, CPU profiles. You can do build and deploy remotely with zero downtime through rolling deployments to a remote cluster. You can manage multiple machines in one place and restart those clusters of Node processes. This would be the equivalent of your 4 PHP processes on your machine, and being able to go in and stop and restart any individual one across multiple machines. So very cool tool for that. So if you're interested in that and you want to get started, strongloop.com/get started. We also, if you're just getting into Node or into JavaScript, our blog is entirely technical with the occasional announcement of being acquired by IBM. Otherwise, it's very technical. We have a lot of really good, not just Node, but also just JavaScript stuff. What's new in ES6? How do you use Ionic to build a native mobile app with Angular? I mean, just a lot of really cool information on that. So check out it's called the Strong Blog. So it's strongloop.com/strongblog. So check that out if you're interested. And that's it for me. The slides are up here, training.strongloop.com/node and PHP, node-and-PHP. These slides will be up relatively permanently, so feel free to bookmark it and check it out later. I'm going to stick around. I might go out for a beverage afterward. Lots of swag. Feel free to hit me up if you have any questions about Node or integrating the two. I'd be happy to talk to you. Thanks. Any questions right now? Yeah.
What, in terms of benchmarks, I don't know if it matters. I use Apache Bench to test. What kind of benchmarks are you guys getting for simultaneous connections and requests? So
simultaneous connections is something that I can tell you, but you're not going to like it, and it's because it is ridiculously more efficient. So if you assume that I've got 4 PHP processes, and each one takes up 200 milliseconds to process a request response, right? And I've got 4 processes, so 200 times 5 gets me 1 second, times 4 gets me 20 requests a second that that 4-process cluster can take. Sound about right? 20 processes a second. So if you say per second, you talk concurrent connections, you're really talking about hits, right?
Yeah.
So 20 requests a second. I can do one node process and easily do, I don't know, 600-700 requests a second. Easily for the same application. And keep in mind that request response time has not changed, right? I'm still processing each request and response in 200 milliseconds. The difference is my node process is being freed up to handle additional requests because all of that database lookup, all the file lookup, all the external REST API lookups, all that stuff is happening asynchronously. Now, eventually your machine will drag down because you've got so many other things going on, which is why you still have to scale, right? There's no getting around that. But the concurrency is insanely high, which is why it's really good for data APIs that are just serving up.
And then when it comes to node clusters, and you have the master process, I would say for just a reasonably scaled server, what are the stats that a computer running that process generally needs to have?
So generally we spin up one node process per core. So if I've got a quad core machine, I'm gonna spin up 4 node processes. If there's nothing else going on in the machine, right? I'm assuming there's no database running on that, it's external. I'm assuming that it's not running some caching mechanism, external caching mechanism, something like that, right? If you just have a machine and all you're doing is running node on it, I would spin up one master and 4 workers. Because the master isn't handling requests, right? It's just delegating. So that would generally be my modus operandi.
I mean, like, it's the assumption that that's going to be able to handle.
I would think
1 million requests a day.
Oh, easily, yeah. So if you're curious about more performance, now I'm not in the production world, right? I'm an evangelist. I do see a lot of statistics, but those statistics are from other companies. If you want to hear live statistics and talk to someone about it, I would talk to this guy right here. Juan, raise your hand. So Juan works for Fluencia, Spanish language online, dictionary online, and learning. And they are running Node in production, right? It is in production, yeah. And I'm sure that he can tell you they get millions of hits, and he can talk to you about those statistics. So hit him up afterward. Thanks. Any other questions about Node and PHP? All right, let's do your thing.
All right.